Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Muhammad Anwar Zamani. My metric number is AE190027. So I will present for the simulation for activity 1. Okay. For activity 1, by using MATLAB Simulink, we need to construct the block diagram of an open loop speed control system. Okay. This figure 8.4 is a MATLAB Simulink diagram for open loop speed control system. This is the MATLAB Simulink on MATLAB software. Okay, for the first one, we need to set up the input speed to 240 volt and break to 0, and the simulation time is 10 seconds. Okay, so step time 0, initial value 0, and final value is 240. Okay, I run this simulation. Okay, wait. Okay, we get the value. For the input voltage, we get 240. For the motor torque, we get 11.02. For the motor speed, we get 3995. For the tachometer voltage, I get 240.2. Okay, and then for the input voltage graph, we get the linear graph, this one. For the motor torque graph, okay, is increase until maybe I think 47 and slowly decrease about 11 or 12. Okay, for the motor speed, I get this graph. This graph is for the motor speed, and the last one graph is tachometer voltage. Oh, it's also same with the motor speed graph. Okay, I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Muhammad Rafiz bin Zulkifli with metric ID AE19006. So next I will present about activity 2 for the experiment 8. So in this activity 2, we repeat the step 4 in activity 1. It's using this parameters. This is used to know what's the input voltage used for this activity 2. So open the MATLAB, and at the question, at the instruction, we use the 2500 RPM. So we set the input speed with 2500 really. Then when we start the run, and it's the input voltage show 162.5 volt. So this is for the input voltage. For next, we go for the second step is to obtain the motor speed by applying different value of brake scales. So here in Simulink, I will show an example for the brake for 21 by using the final value 2500 with the input voltage 162.5. So this is exactly the same circuit that I used to find the input voltage because I connected it together, which to determine the output voltage and the motor speed. So here with 21 break, we get 884.6. And this is the voltage graph. And this is the motor speed graph. So for the graph of this motor speed against the brake scales, it seems like this. It's indirectly proportional. The brake scale is indirectly proportional with the motor speed, which is this decreasing by the motor speed. So that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Ridwan. So I will explain the simulation for exercise number 3. Okay, so basically this is the circuit that I already constructed in the MATLAB. So we just need to change the value accordingly to the table 8.1. For the circuit, we just need to double click the transfer function to change the value. So we just need to change the value here. Just insert the value according to the table 8.1. Then for the input voltage, we need to set the value of to the 162.5. So you just need to type here, and then I'll click OK for the input voltage. And now for the proportional, again we set the value of 200 according to the table 8.4. For the saturation, we set the upper limit to 240 and the upper limit is 0, also according to the table 8.4. So now we need to set the value of brake scale to 0 for the first case. And also don't forget to check the value of another parameter of the another gain. So now the brake scale value is 0. So we can just run for the simulation to observe the circuit and the output value of a speed motor. Okay, so this is the value for the first case of brake scale of 0. So we just need to record the value in the table 8.5. And so this is the graph of motor speed. So the value then we record in the table 8.5. So now according to the table, we need to change the value of brake scale to 3. And just repeat the same step. We run the simulation to observe the graph and speed motor output for this brake scale of 3. So now this is the value of output motor. So we just record in the table 8.5 and then we observe the graph for the brake scale of 3. And then we need to change the value of brake scale to value according to the table 8.5. So just change the value according to the table, and then we just repeat the same step of brake scale 0 and 3 to find the motor speed output and the graph for the motor speed. So that's all for exercise number 3.